Well, hello, chemistry team. Dr. Locks, your chemistry coach, coming at you. We're going to do a quick little video on how to use burets. We're going to use these for a couple labs later on, titrations and things like that, density labs, which are based 100% on your skills in using burets. So let's walk through that a little bit. So first, we keep our burets in our labs stored up on the top part so they're not in our way. So if you need them, you just grab them. Pull them down so you can grab them by the buret stand like this. And we always have two burets here. Normally when we do a titration, we have an acid with a base or an oxidizing agent with a reducing agent. So it's nice to have two burets here. But we keep them in the stand, all nice and simple. And we use what are called Mohr burets, M-O-H-R. So if you've done labs before with burets, so what I can do is I can just unclamp this here. So if you look at it, these have these little pinch clamps, so I can just pinch this like this, boop, and it comes out, and I can squeeze it, pop it back in. So you can pull these in and out quite readily when you're doing it. So if you look at it, this might be a little different than what you used before. I know most of my college life, actually all of my college life, I used a buret that had a little plastic turn nozzle on it, which worked okay for, simple labs, but we use an Mohr Mohr buret, which is just some plastic tubing with a little half pipe, glass pipette thing, and a glass bead here. This will give you a lot more fine control, so you'll get better accuracy and better precision. At least when I do it with myself and when I teach classes that use the plastic turn nozzle ones versus these always have better precision and better accuracy, sometimes by orders of magnitude. It's pretty crazy because with the plastic one, a lot of times you can't get bubbles out of here, right? You get little bubbles form in there and you can't get them out, where these you can control just about everything. So whenever you see this is an Mohr or Mohr buret. Give me more burets. Hopefully you printed out, if you haven't, the buret instructions. So who'd have thunk there's so many ways you could screw this up. It seems pretty simple. We're not even going to do titration demos. It's just how do we get stuff out of there. And all it is a volume transfer device. That's all it is. So we've got a starting point of, it starts at 0 way up here. Unfortunately, the tape's pretty much on it, but I don't know if you can see the 0 there. So it starts at 0 right there. And then it goes down to a bottom line here, which is at 50. Don't go below that bottom line. There's no graduations anymore. So you can look at this and calculate the increment, the family, and the absolute uncertainty and figure out how many decimal places you can read that to. Pretty consistent. Some have red, some have white, some have black ink. So it just depends. Some people see different colors a little bit better. The reason it starts at 0 and ends at 50, why is it upside down like that? Because when we transfer liquid, it's not like, you can measure volumes out of this, but it's not like a graduated cylinder where you just fill it up and it starts at 0 and goes to whatever. You can just read it directly off there. This is a variable volume transfer mechanism device where I can dispense any amount of liquid, even if I don't know how much I need. That's why it's great for titrations. So you just start somewhere up close to 0. It doesn't matter where you start. You don't have to start at 0.00. No point, because all we're interested is where do we start, and then you drain out what you need, and let's say you end here. So this would be your initial volume. This would be your final volume. And delta V, or the change in volume, is the final minus the initial. Well, volume can't be negative, right? So if you want to get a positive volume, you need to take a bigger number minus a smaller number. So the final volume has to be bigger than the initial volume. That is why burets look upside down. They start at 0 and go down to 50 because you have to have a bigger number on the bottom, which is your final. So you take your final volume minus your initial, and you get a positive value. That's why that is so. And that's covered in number 4, at least on my instructions there. So a couple things to watch out for. Now, each of these little boo-boos might seem simplistic, but if you do 2 or 3 or 4 of them, I mean, that can be the difference between an A and a C when you're doing your experiments. And I have incredibly high expectations. I want you to be at the master level, some expert level. I expect great results. If you follow what we teach, you should be able to get great results. Now, at our college here, we store these with DI water. And so what we like to do, if you're going to do an experiment with this, we need to get rid of this DI water. So what we do is I'll just get a a beaker here, and I'll just pour this water out into this beaker, put a little piece of tape that says DI water, and save it. So when I'm done with the experiment at the end of the day and I clean these out, I can pour the original water back in and then store it properly. All right, so that's it, because DI water costs money, right? And then maybe every couple weeks I'll dump that out and replace it with some fresh DI water. So just a note that we store that. And then obviously when we empty this out, this will have a coating of deionized water. Well, that's not good. Whatever liquid was in here, even if you drain it out as much as you can, there'll still be some attached liquid in here, whether it was water or some prior solution. So if I want to put a new solution in here, so let's say I dump this water out and I want to put an acid solution in there, I can't just pour the acid in there. It'll collect that surface layer of deionized water and contaminate it, change its concentration, change its density. Big problem students have is contamination with a prior substance. So what you want to do is condition it out, all right? And I'll show you briefly how to do that in a little bit. Let's talk about how these work. So real quick, I'm not really going in order off of this list here, but you can't dispense any liquid if the stopper's in it. And we'll talk about why that is in a second. What we're going to do is to get liquid out, see that where the bead is? You don't pinch the bead. You're pulling the plastic away from the bead on this side, or you can reach across and push the plastic away. One way I do that, if I'm doing it for a large group, I'd say hold up your finger. Watch out for the finger. If your knuckle's that glass bead, your skin is the plastic tubing. So I can pull the skin, right? So I can pull the skin away from my knuckle. See that? And if my fingers get tired doing that, I can reach across and push the skin away from my knuckle. See? I actually prefer to do that. I like to reach across and push away from the bead. It's easier on my finger. But you can still pull this way. And you need to be able to do it with both hands. You could do it this way and this way. So you don't want to squeeze the bead because then the bead can shoot up or down. So if you're doing this and you see the bead moving, you're not doing it right. If bubbles are in, if there's no bubbles to start with and then there's bubbles all of a sudden, you're not doing it right. Okay? Because you'll see that if you squeeze below here, bubbles get incorporated into it. So you're just what you do, and when you stretch that plastic away from the bead, it creates a little air gap, which allows gravity to pull the liquid down. So if the stopper's in, gravity can't do its thing. So if you're doing this, you're like, the veins are popping out and you're turning red, and it happens every year. I'll be like, oh, take the stopper out. Just keep that stopper. I like to keep it up here so I don't lose it. So now I can dispense the liquid properly out of the burette. Now make sure that it's in this burette holder proper and vertical. I don't know if you can see this. So when you put it in there, you want to make sure it's nice and straight. You don't want it in at a funny angle. See, from my point of view, that looks straight. From your point of view, it's crooked, isn't it? So there's some grooves here it's got to fit in. So always make sure your burette's vertical, otherwise you're going to get some issues with your volume readings, all right? So check that out. So stopper's out. So let's show you real quick how we're going to dispense the liquid out of here. Let me zoom it in. Whoop, where's my zoom button? Haha. Here we go. So let's pull that up a little bit so you can see the bead. There we are. So I've got the bead here. A little too close. There. So if I'm going to dispense this, again, I'm pinching the side of the plastic tubing, and you can dispense this at a pretty quick rate if you want to. Like I can go at a stream. See that stream coming out? I can slow it down to a fast drip like that. I can do a slow drip. I can do one drop at a time. I can do one drop, tap it off like in a titration. I can do a half a drop, tap it off. I could even do a quarter drop, tap it off. What? Yes, you can. Right? You have incredible, these Mohr burettes are awesome. You have complete control. And when you're doing titrations later, I expect you to get a color change with a half a drop or less, where this is, say this is colorless, and you do a half a drop or less and tap it off in an Erlenmeyer flask, swirl it down, poof, you get the color change. Whoa, that's what I'm talking about. That's good stuff. Total fine control over this. Although when you're draining it out, you don't want to go more than about 0.5 mil per second. So if I'm draining this out, let me show you this. I'll zoom in again. Here we are. So I'm going to watch my Buret and go about 0.5 mil per second, and you watch the drainage rate. So let's see. So 1/1000, 1/1000. That's about 0.5 mil per second. That's about how fast you want to be going. So it's like a really fast drip or a slow stream. You don't want to be like, wah, as fast as you can, because that can create some issues. So let me show you why. When this is draining down, I can't pull this too much lower. So if I'm draining this down as fast as I can, what happens is, see how that's coming down? If I'm going too fast, see how fast I'm going? That's way too fast. What's happening is the bulk of the liquid's coming down, but there's a stream of water sticking to the sides of the glass, and you form a little comet tail. So the bulk is coming down with a little trail going, wait for me! So if I'm like, meow, meow, going too fast, and I stop and I read my volume, right, I read it here, and then this liquid trickles down, that will start dribbling back up, and now you got a volume that's very incorrect, right? So one of the biggest mistakes students make is they drain way too fast. Another thing, it's not a mistake, but if they're so paranoid about that, they go way too slow, and it takes them all day just to do a couple of, say I expect you to do 5 or 6 titrations in one day, and they only get 2 done because they're so paranoid of going too fast. Well, they've done studies, and you can go about 0.5 mil per second and avoid that issue of the liquid sticking up on the sides. If you're super paranoid, maybe, 0.3 milliliter per second, you're good to go. But if you start seeing that, if you're measuring densities, right? And if you go too fast, you're going to measure a lower value, which means it's a bigger volume. So I see that a lot when people, density's mass over volume, right? If the volumes are too big because you're draining it too fast, and you're consistently getting smaller densities because you have the mass divided by the volume. If the volume's too big, the density's too low. So I'll see people who consistently get way low densities, but they're consistent and precise. If that's the case, I'll be like, I think you have a systematic error. You're draining it too fast and you're reading the volume too quickly. So I like to drain it at about 0.5 mil per second max. And then I'll wait for maybe 10 seconds or so to give any of it dribbling down a chance to collect, and then I'll read it. And I usually don't get those volume errors. So be very, very careful with that. I'm moving on to the back page. We want to get all the bubbles out. So if you've got bubbles in your tubing before you start, that's going to be a huge volume error. So when you're doing this, let me pause this, and I'm going to incorporate some bubbles into here. All right, let's see if this helps a little bit. So if you look in here, can you see this big bubble right here that's above the bead? You don't want that. So all you do, if it's above the bead, you can just push it out and just go, ugh, right? Just push it out and the bubbles just rise up because they're less dense. So that allows you to get all the bubbles out above the bead right here. But now you see this big air gap below the bead and above the pipette tip. You can't push that out. That's too hard. So what you do is it's like if you're giving a shot, right? You turn the shot upside down. I got a 3-legged diabetic cat. And what I do when I have that, we have to give them shots, you get the insulin, you turn the shot upside down, and you squeeze it until the air comes out. See what I'm saying? You don't want to jack the air into the cat or a human, inject air into their bloodstream and they get a stroke or something like that. I'm not that kind of a doctor, but then not that kind of doctor. But I know you don't want to inject air into somebody. So it's the same idea. You just turn it upside down, squeeze it, and the air comes out. And once you see liquid squirt out, then you know all the air is gone. So I'm going to do the same thing. I'm going to twist it perfectly. You don't want it at an angle. You want it perfectly vertical. Don't pinch the tubing. The tubing has to be open. And then I'll hold it with another hand like that. Now this is just water, so if I did it, I'd get water on me. I want you to see it. Normally I would take paper towel. Let me grab a paper towel here. Normally I would grab a paper towel and I would wrap it around here because I don't want to get any solutions on my hand, right? I'd wrap it around and then pinch it and the liquid would drain into here. So let's see if we can do that, okay? So can you see the air pocket here? So I'm going to pinch this tubing to the side of the bead like I normally would. Now watch the air come up. See how that bubble rises out? Boop! And now I have no air bubble between here and here. Now I do have a little air gap at the tip, and what I'll do is I'll just squirt that out, get a little drop hanging off, let go, and tap it off. You want to let go and then tap it off, because if you squeeze the drop, tap it off, and then let go, by letting go, it pulls air back in. So now, see how flush I am in the top there? Always make sure it's dry, and you're good to go. So that is a very useful way of doing these. Make sure there's no bubbles in there. Always do that before you read your initial volume. No bubbles in there. And then get it up close. Don't waste it on 0.00. Just get it close to 0.00. And you're probably good. Always use a Buret reading card when you're using this. So let me go grab one real quick. All right. So just like if you're using graduated cylinders, always read it with a Buret reading card. So you wouldn't do this in your hand. This would be in the Buret, but I want you to be able to see it. So if you hold it up, right, and rotate it so you can see it, and then just bring the top of that black rectangle till it's just below, and then you can see the bottom of that meniscus outline in black. So I'm not able to zoom in. We're not here. We're going to learn how to read those in a different lab, but always use that Buret reading card. Very critical. When you're done for the day, what you'll do is you'll condition it. And conditioning is the same when you're getting rid of the water or getting rid of a solution. What you're going to do is you're going to have a waste beaker. So let's say I have a waste beaker here. Let's get rid of the rest. So let's say this is the original DI water, and I want to put an acid solution in there. Or let's say I'm done with the day and this is my acid solution, and I want to clean up and store it with DI water. So I'm going to drain out. So let's say this is the acid solution. I want to get rid of it. So I'll drain out as much as I can into a waste beaker and put that in the appropriate waste container, or acids and bases can go down the sink. So this is coated with that acid layer or whatever the prior liquid is. So what I want to do is rinse it out. I want to condition it 4 times. So I'm going to spray in my DI water, or if I was conditioning it with a base solution or an acid solution or a salt solution, I would use that. So I like to use 7 to 10 milliliters or something like that. Have my waste container like this, and then what I can do is I'm going to get rid of all the bubbles. So I'm going to spray some out. On my first rinse, I rinse it 4 times. The first rinse, I get rid of all the bubbles, just like I showed you to do before. So I got to get that bubble out there. So I'm going to pinch that out of there. Bye-bye. There, so now the bubbles are out, so I can clean that real well. So I'm going to rotate this like a merry-go-round, because I want to make sure I'm cleaning every possible side of this this bead, not just one side. So I am pinching every possible angle. So what I do is I just push the plastic to the side of the bead at the same spot, and then rotate the Buret around in circles like I'm on a merry-go-round. That way I'm sure I get all 360 degrees. I rinse all 360 degrees with the solution that's going in there. So that's always my first rinse. And then I'll squirt in another, 6, 7 milliliters, whatever. And what we're going to do is the old cement truck maneuver. I'm going to rotate this around, and I'm going to so I've got the liquid. Don't dump it out on your friend or something. And so what you're doing is you're just having the liquid go up, and you're rotating it, and you're collecting the surface layer of the prior liquid with the new liquid, rotating, and then you just drain that out into your waste container. And you do that 2 more times. Don't ever drain it below here, because then you get bubbles back in. So the first one really focuses on getting bubbles out, rinsing the tubing and the bead. And then the second, third, and fourth rinses when you're conditioning or acclimating or passivating, i.e. switching into a new solution. You're getting all of this in there. And do that 4 times. I'm not going to waste my time doing it. Let's say we did that 4 times, right? Let's say it's the end of the day. I know I got all the acid or base or whatever solution was out of there. I'm going to go back to the original deionized water that I had in there, right? Which I saved in here. And then I can pour that back in, and we can store the Buret for the day. Now, in an actual lab, I'm going to check these. I want to make sure you've cleaned this properly. I didn't have enough in there, so I'm just going to fill the rest up with this DI water. And what I'm going to do is get that filled all the way to the top. And there's a little trick I do. It's not real critical, but I want to make sure that when you put the stopper back in, there's no air gap. Like if I put the stopper in here, see how there's an air gap between the stopper and the liquid? I don't want that. It's not a key thing, but I know if you make sure it's not there, you're doing something properly. So I want you to fill it up all the way to the brim. And then as I push the stopper, now don't just shove the stopper in because the pressure will displace an equivalent volume and push the bead down. I need to release the pressure at the bead. So as I'm pressing the stopper down with my thumb on my right hand or left hand, I'm releasing pressure by pulling or pushing the plastic on either side of the bead so that the liquid that's displaced from the stopper comes out. So I can only show you this. So I'm going to put the stopper up on top, but I'm not pushing it down. And what I'm going to do, if you can see this, I'm going to, as I push in, watch the liquid come out. Boop! You see that liquid come out? That was due to me pushing the stopper in. And then I'm just going to dry this off. So I got no bubbles, the bead didn't get pushed down, and it's nice and flush. You don't see any air gaps there. And then you would come up and say, hey, teacher, Dr. Locks, Doc, Coach, whatever you call us. And I would check it, make sure there's no bubbles, the bead's in the right spot, the stopper looks good, and I sign you off. If it's not, I say, I don't think you cleaned it right. Do it again. So anyway, that's just an overview of burets. We're going to be doing a lot of labs with these. This just gives you an idea of what you need to watch out for.